Join me as I dive into 10 minutes of the most unbelievable cosmic theories. We're venturing into the farthest reaches of space and time, exploring concepts that sound like science fiction, but are grounded in scientific inquiry. Cosmic theories fascinate us because they give us a glimpse into the workings of the universe and our place in it. They invite us to ponder profound questions about our existence. Where did we come from? Are we alone? What is the ultimate fate of the universe? Science isn't afraid to ask big questions, challenge the status quo, and seek new knowledge. Our first stop is the shadowy realm of dark matter, a mysterious substance making up about 27% of the universe. We can't see it directly because it doesn't interact with light like familiar matter. So how do we know it's there? Imagine galaxies swirling around, seemingly defying the laws of gravity. The visible matter isn't enough to hold them together. Enter dark matter, providing the extra gravitational pull to keep these cosmic dancers from spinning off into the void. Think of it like a tablecloth held taut at its corners, with a bowling ball in the center causing the fabric to sag. But what if you saw strange ripples and distortions around the bowling ball, as if there were invisible objects hidden beneath the tablecloth? That's dark matter. Astronomers have been chasing this elusive phantom for decades, trying to pin down its identity. Is it made up of exotic particles we haven't discovered yet? Could it be whispering secrets about the very nature of the universe? The search continues, and the answers, when we find them, are sure to revolutionize our understanding of the cosmos. Fasten your seatbelts, because we're about to embark on a journey through wormholes, theoretical tunnels that could connect distant points in space-time. Imagine folding a piece of paper in half and poking a hole through it. That hole is a two-dimensional representation of a wormhole. A wormhole could potentially allow us to bypass the immense distances between stars and galaxies, making interstellar travel a possibility. Instead of traversing the vast cosmic ocean, we could take a shortcut through a wormhole, emerging on the other side of the universe in the blink of an eye. Of course, wormholes remain firmly in the realm of speculation. They emerge from the mind-bending equations of Einstein's theory of general relativity, which describes gravity as the curvature of space-time. Creating a wormhole would require unimaginable amounts of energy, perhaps even harnessing the power of exotic matter, a substance with negative mass. And even if we could create a wormhole, its stability would be a major concern. The possibility of wormholes, however remote, sparks the imagination and reminds us that the universe is full of surprises. Hold on to your hats, folks, because things are about to get really weird. We're diving into the mind-boggling concept of the multiverse, the idea that our universe is just one of many, perhaps an infinite number of universes, coexisting like bubbles in a cosmic foam. Imagine a vast cosmic ocean filled with countless bubbles, each representing a separate universe with its own unique laws of physics, its own cosmic history, its own possibilities. In some universes, gravity might be weaker, stars might be made of antimatter, and perhaps, in some, you and I are living completely different lives. The multiverse arises from various theoretical frameworks, including string theory and inflationary cosmology. String theory suggests that the universe has more dimensions than we can perceive, curled up at an incredibly small scale. These extra dimensions could give rise to a vast landscape of possible universes, each with its own set of physical constants. Inflationary cosmology proposes that the universe underwent a period of exponential expansion in the first fraction of a second after the Big Bang. While the multiverse remains a theoretical construct, the mere possibility of its existence opens up a universe of wonder and endless possibilities. Prepare to have your minds blown wide open as we explore the concept of an expanding universe. A universe that's constantly stretching, growing, and evolving. Picture a balloon with dots scattered across its surface. Now, imagine inflating that balloon. As the balloon expands, the dots move farther apart from each other. That's essentially what's happening to our universe. Galaxies, like those dots on the balloon, are moving away from each other. Not because they're moving through space, but because the very fabric of space itself is expanding. This expansion was first observed by astronomer Edwin Hubble in the 1920s, who noticed that the light from distant galaxies was stretched or redshifted, indicating that they were moving away from us. The farther away a galaxy is, the faster it's receding, like runners sprinting away from a starting line. The expansion of the universe is one of the most profound discoveries in cosmology. with far-reaching implications for the fate of our universe. Will it continue to expand forever, growing colder and darker as galaxies drift farther apart? Or will gravity eventually halt the expansion, causing the universe to collapse in on itself in a fiery big crunch? Hold on tight, because we're about to delve into the enigmatic realm of dark energy, the mysterious force that's accelerating the expansion of the universe. Imagine a car cruising down a highway, its foot gently on the gas pedal. Suddenly, the car lurches forward, accelerating at an alarming rate as if an invisible force is pushing it from behind. That, in essence, is what's happening to our universe. For decades, astronomers assumed that the expansion of the universe was gradually slowing down like a ball rolling uphill against the pull of gravity. However, in the late 1990s, observations of distant supernovae revealed something astonishing. The expansion of the universe wasn't slowing down, it was speeding up. The culprit behind this cosmic acceleration: dark energy, a mysterious force that makes up about 68% of the universe's total energy density. Some speculate that it's a property of space itself, an inherent energy embedded in the very fabric of the cosmos. Others propose that it's a new type of field dubbed quintessence that permeates all of space. Whatever its true nature, dark energy is a powerful force, one that's shaping the evolution of the universe on the grandest scales. Prepare to enter the realm of mind-bending physics as we explore the holographic principle, suggesting our reality might be a projection of information on a distant two-dimensional surface. Imagine our universe as a giant hologram, a projection of information stored on a distant surface. This idea arises from black holes, which emit Hawking radiation, carrying information about their internal state. The holographic principle suggests this information is encoded on the event horizon, projecting a three-dimensional image. Some physicists believe this principle might apply to the entire universe, reshaping our understanding of reality. Fasten your seatbelts, because we're about to embark on a journey back in time to the very beginning of our universe, to the moment of the Big Bang. Imagine a universe smaller than an atom, incredibly hot and dense, a cosmic soup of energy and matter. Then suddenly an explosion, an expansion, a burst of energy that set the universe on its evolutionary path. This, my friends, is the Big Bang Theory, the prevailing cosmological model for the universe. It's a stepping stone, a foundation upon which future discoveries will be built. Hold on tight, because we're about to embark on a mind-bending journey through the earliest moments of the universe to a period of exponential expansion known as cosmic inflation. Imagine a universe smaller than an atom suddenly inflating at an unimaginable rate, faster than the speed of light, stretching and smoothing out the fabric of space-time like a cosmic iron. This rapid expansion, which occurred in the first fraction of a second after the Big Bang, is thought to have played a crucial role in shaping the large-scale structure of the universe we observe today. Cosmic inflation offers elegant solutions to the horizon and flatness problems, explaining the uniformity of the cosmic microwave background radiation and the universe's flat geometry. Enter the mind-bending world of string theory, a framework unifying all fundamental forces of nature. Imagine matter's building blocks as tiny vibrating strings like strands of energy. These strings vibrate in different modes, creating particles like electrons and quarks. String theory unifies quantum mechanics and general relativity. It addresses extreme environments like the Big Bang and black holes, proposing particles and space-time as vibrating strings. String theory requires extra dimensions beyond our everyday experience. These dimensions are curled up at an incredibly small scale. Prepare to enter the bizarre and counterintuitive world of quantum mechanics, the theory that governs the behavior of particles at the atomic and subatomic level. In this realm, the classical laws of physics we're familiar with break down, replaced by a set of rules that seem stranger than fiction. Imagine a world where particles can exist in multiple states at once, where they can tunnel through impenetrable barriers, and where their properties are determined by probabilities rather than certainties. This is the strange and wonderful world of quantum mechanics. One of the most mind-boggling concepts in quantum mechanics is superposition, the idea that a particle can exist in multiple states simultaneously until it is measured. Imagine a coin spinning in the air, neither heads nor tails until it lands. Similarly, an electron before it is observed exists in a superposition of states, both a wave and a particle, its properties smeared out like a blurry photograph. Another bizarre phenomenon in quantum mechanics is entanglement, a spooky connection that can exist between two particles, no matter how far apart they are. This seemingly impossible connection has been experimentally verified, defying our classical intuitions about space and time. So, what do you think about these cosmic theories? Do you have a favorite one that blows your mind? Let me know in the comments below. Which one sparked your curiosity the most? Thanks for watching, and I'll catch you in the next video. Until then, keep looking up at the stars and never stop questioning the universe around us.